Subtracting fractions works the same as adding fractions, but let's go through its rules right from the beginning. If we want to subtract 2/3 minus 1/5, we have to have a common denominator. So we need to know the multiples of 3 and 5. I'm going to draw them here. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, and it keeps going. The multiples of 5 are 5, 10, 15, 20, 25. It keeps going. I look for the lowest number that's in both lists, which in this case is the 15. So, I want to convert 2/3 and 1/5 into fractions over 15. The 3 has to be converted into a 15, and I do that by multiplying it by a 5. So therefore the 2 has to also be multiplied by a 5, and 2 times 5 is 10. 5 is converted into 15 by multiplying it by 3, so the 1 has to be multiplied by a 3, and I get 3 over 15. Now that they are both over the common denominator of 15, I can say 10 fifteenths minus 3 fifteenths must be equal to 7 fifteenths, and I have my answer. Of course there is a shortcut. 3 times 5 is 15. So we can get a common denominator simply by multiplying the 3 and the 5. If we multiply the denominators of our starting fractions, we get a common denominator. But it's not always going to be the lowest common denominator. So let's see a few more examples and see how that plays out. Here we have 11/12 minus 7/12. Well, our denominator happens to already be common. So we have a really easy one here. We can just answer the question. 11 minus 7 is 4. Our answer is 4/12, which reduces, if I divide top and bottom by 4, into 1/3. It's not always so easy though. In this case, we have 17 over 18 minus 2 over 9. If we list the multiples of 18 and 9, we get 18, 36, 54, and it keeps going. For 9, we get 9, 18, 27, 36, and it keeps going. And the lowest number that's on both lists is the 18. It turns out that our lowest common denominator is already the denominator of one of our fractions. That doesn't matter, we can still go about it the same way. 17 over 18 stays the same. The 9 has to be multiplied by 2 to give 18, so the 2 has to be multiplied by 2 to give a 4. 17 eighteenths minus 4 eighteenths is equal to 13 eighteenths, and we have our answer. If we had tried the trick of just multiplying the denominators we already have, would we get the right answer? Let's try it. 18 times 9 is equal to 162. So we would have to put both fractions over 162. That's a rather large number. But 18 is converted into 162 by multiplying it by a 9. So we have to multiply the 17 by a 9, and we get 153. 9 is multiplied by an 18 to give 162, so the 2 has to be multiplied by an 18 and gives a 36. If we subtract 153 over 162 minus 36 over 162, we get 117 over 162. Can this fraction be reduced? These two numbers have a common factor of 9. 117 divided by 9 is 13. And 162 divided by 9 is 18. So I have to reduce the fraction I got as my answer. And it turns out that I have 13 eighteenths, which is what I got when I used the more efficient lowest common denominator. So what happened is multiplying those two gave me a common denominator, and that's convenient. It will give me the right answer, but my right answer will have to be reduced to give me the type of right answer that will get me full marks on a test question. If I use this method and make sure I use the lowest common denominator, then I get an already reduced final answer, which is correct without having to do the extra step. Either method will work, and they are just as good as each other. This is how you subtract fractions.